Hi, I am Varun Joshi and I welcome you to Cloud with Varjosh. In this lecture, we are going to look at Maven from a DevOps engineer's lens. We will start with compiled versus interpreted languages, then see why build tools exist and where Maven fits. From there, we will install Maven, create a project with demo 1, and really unpack pom.xml, life cycles, phases, plugins, and goals. Then we'll also look into repositories and what are their roles. We will also touch on parent and superpom briefly so you see how real enterprise projects are wired. Finally, in demo 2, we will run a full flow, build with Maven in Jenkins, and run the app as a Docker container. By the end of this lecture, you will be able to read any pom.xml, understand what Maven is doing in the CI, and fix common Maven build issues with a DevOps mindset. With that said, let's get started. So, before we talk about Maven, I think it makes sense for you to first understand programming languages at a very high level because these are the languages for which build tools are used. For some of them, build tools are used, and for some of them, build tools are used, but they are used from a different lens. So, to understand that deeply, let's first understand compiled versus interpreted languages. Now, compiled languages are the languages which require translation. So, for example, if I have the code with me, that code first must be converted into a machine readable format, and that machine readable format could be converting that source code into machine code or into bytecode. So when you are converting the source code into machine code, this is primarily done for languages like C, C++, and Go. If I talk about converting the source code to bytecode, then this is generally done for Java, C Sharp, and so on. Now, I am using the word converting, but I should use the word compiling. The source code for compiled languages requires compilation. So, when I talk about machine code, it is CPU native. So, if I talk about languages like C, C++, Go, any code that is written in that language, the application for that can be directly deployed into your operating system. Of course, you will need certain libraries, but when I talk about modern applications, they have everything inbuilt. So they just need to be installed onto your OS. And once that is done, they can run just fine. But when I talk about compilation, which results in the conversion to bytecode, in that scenario, you require a runtime, and that runtime for Java language is JVM. Now, JVM is not the only runtime that can be used for Java. Anything that converts the source code into JVM bytecode, and the languages for that are also Kotlin, Scala, and Groovy. JVM as the runtime can be used for that. Now, this is too much of information. I understand that. You will need all this information because while you are working with these languages, you will have to understand how they run and how the compilation for them work. Now, we will see this briefly as we progress with this lecture about JVM. So, for now, just understand in compiled languages, you translate the source code, you compile the source code from a human readable format to a format that is understandable by machines. And that format is either machine code or bytecode. So, compiled languages requires build stage, and that is obvious. So if I want my language to be converted into, to be compiled into machine code or bytecode, then I require a build stage, and in that build stage I will perform that conversion. Hence, when I talk about compiled languages, they will always require a build tool, and one function of that build tool will always be compiling. And hence, compiled languages always require a build tool that will do compilation for them. Next is faster execution, CPU direct. Compiled languages are often faster when compared with interpreted languages. Code hidden, binary only. That is true. So once your source code gets compiled, it gets compiled into dot class or dot jar, and there is packaging also, and we'll dissect these terms as we progress with this lecture. But the resultant artifact that you deploy onto your operating system, or you deploy that onto your Kubernetes platform, that code is hidden. You just see the binary and you cannot perform that reverse conversion. Examples of compiled languages are Java, C++, Go, Rust, etc. Now, this is not a comprehensive list. There are many more languages, and I will let you see what those are. Then let's talk about interpreted languages. These languages do not require any compilation. So when I talk about build tools, they are still needed for interpreted languages, but they do not have to perform compilation. But Varun, if I do not have to perform compilation, then why do I need a build tool? Why do I have a point here that says may still benefit from build stage? That is because you still have to do dependency management, and dependency management is not an easy job, like we will see as we progress with this lecture. So for now, understand that interpreted languages, they also require a build tool. They are typically slower. Now, previously, the interpretation you was performed line by line by the interpreter, so these were really slow. But now modern advancements, they are not that slow, but they are still slow when compared with compiled languages. Code visible. So if you have a Python script or a JavaScript, you would essentially share the whole code if you want to ship that application. Anyone who wants to deploy that application, you will have to share that code, which is why it is said the code is visible. If you have worked with AWS Lambda, then you would see that if you are using Python to write your automation, you have to share the entire script. There is no way to share a binary, which you would do when I talk about compiled languages. Now, before I wrap up this section, I want to quickly discuss what are the build tools that are often used. So if I talk about Java, the build tool that is very famous for Java is called Maven, and the second one that you could also see in production is Gradle. And as we progress with this lecture, we will learn more about Maven, because the lecture is called Maven for DevOps. Then for C and C++, there are other build tools. But for now, I want you to understand that when I talk about compiled languages, they require a compilation stage, and for compilation to be performed, there must be a compiler that is performing that role. If I talk about Java, that compiler is Java C. And the artifact format, what is an artifact? Artifact is anything that results from a build. For example, if you are building a container image using Docker commands, then the resultant container image is an artifact. Similarly, if I talk about programming languages, if I'm compiling something, anything that results from that, that could be .class file, .jar file, .var file, .year file. When I talk about Java, this is called an artifact. So anything that results from a build is an artifact. Let's read what is written here. Build tools don't just invoke compilers. Now, with this definition, you could be thinking that build tools are just used for compilation, but it is not like that. they do so much more. They handle dependencies, and this is an important task. For example, if I'm writing a banking application, then I would of course need a calculator to calculate the interest rates or to calculate the loans and so on. But I will not ask my developers to write the code for calculator. What they would do is they would use a well known library so that they do not have to write the code for calculator again, and that library when used becomes a dependency. So a crisp definition for dependency is anything on which your application depends. Now that could be a library, that could be a configuration file, or an IP address. So anything on which your application depends is a dependency. Now when I talk about build tools, they will handle dependencies for you. For example, if my application depends on a calculator library, then my build tool will fetch that library for me. And not just that, maybe that calculator library in turn depends on another library. So that will also be taken care by my build tool. And this is called transitive dependency. One dependency depends on another dependency. That is called a transitive dependency. Not just compilation and handling dependencies, build tools will also do packaging, testing, and artifact publishing for you. Varun, what is artifact publishing? Packaging is packing your application source code into .jar, .class, or .var, and these are just formats of your artifact. So if you are working with a Java application, you would typically see .jar being used, but .var and .year could also be seen. War is for web apps, year is for enterprise. Then packaging is that, but what is artifact publishing? Understand that when you generate your container images, you are uploading those container images somewhere, right? And that somewhere is typically your image registry. It could be Docker Hub, or it could be any cloud native offering that you are leveraging. When I talk about artifacts that are result of build, container images are one. Second could be .jar and .var. These artifacts can also be published, and they are often published. But Varun, where are they published? Where are they uploaded? For container images, we have image registries, container registries. But when I talk about these artifacts, these are often stored in solutions like Sonatype Nexus, JFrog Artifactory, or you could also be leveraging any artifact storage provided by your cloud provider. So for now, what I want you to take away is build tools don't just invoke compilers, they handle dependencies, packaging, tests, and artifact publishing. With that understanding, let's see what I want to discuss next. Why and what of build tools? Automate source to artifact conversion reliably. We have seen this. Resolve dependencies, including transitive chains. For example, if my application depends on A, but A depends on B, and B depends on C, and C depends on D and E, then my build tool will take care of everything, not just immediate dependency, but also any transitive chains. Lock versions for reproducible builds. Now what happens is, when I want you to understand this or contrast this with containerization. So I'm saying lock versions for reproducible builds. So whenever you are creating a container image, you use a Docker file, and in that Docker file you provide the version of the base image that you wish to use, and every time you build the container image, that version is used. Similarly, when I talk about build tools, they also lock versions. So they have a file oftentimes where you provide these are the versions of dependencies that I wish to use, and you must install the same version while I am building my software or application. And not just compiled languages, even interpreted languages. If I talk about Python, you use a package manager called pip, and pip is the one that is taking care of your dependencies. With pip, you have a file called requirements.txt. With Python, you use a file called requirements.txt, and this file will have all the versions of the dependencies that you wish to use along with your application. Hence, the build tools, once you provide your inputs, will freeze the version that your application requires for the dependencies. Hence, we are saying lock versions for a reproducible build. So whoever is building your application or whoever is building your software, they already know that the application that I am building right now requires these dependencies, and this is the version of these dependencies. Hence, wherever that application is built, it builds and performs the same way. Compile or prepare code consistently, and we have already discussed this. Not just this, build tools will also run tests for you, and these tests could be unit tests or integration tests. Linters, linting is a process in which you check your code for errors, bugs, style issues before it runs, and it will also point out any unused variables. And then there are, of course, security scans. So your build tools are capable of performing all these things. Now, there are plenty of build tools available. In this lecture, we'll be discussing Maven, but understand, if you are using any other build tools, they may offer similar functionality for different languages. For example, Maven is primarily used for Java, although it can be used for other languages, but primarily it is used for Java. Hence, Maven is capable of performing all these things. Now, your build tool may not be able to perform a certain functionality, but understand that at large, at a very high level, build tools are expected to perform the functionalities that we are discussing in this lecture. But this lecture is specifically for Maven, so whatever I'm saying for build tools, that is applicable for Maven for sure. For other build tools, you may have to check the documentation. Next is package and publish reproducible artifacts, and this we have already discussed. Packaging and publishing. Packaging is converting your source code into .jar, .var, or any other format. So if you look at here, see, maybe .out, .exe file, maybe .so or .dll files, whatever is an artifact, whatever packaging format your languages support, the build tools will be able to package your source code in that format and then publish. As we already know, publish is essentially uploading your artifact into a central repository so that other team members can also use it. And the next one is eliminate environment drift and manual errors, and this is self-explanatory. If you have defined everything in your build tools, specifically the versions, then it eliminates environment drifts and manual errors. Why eliminate environment drifts? Because your application is going to run the same way in all the environments, because you have defined the versions that your application is supposed to use for dependencies. Hence, everything is streamlined. So all these functionalities are performed by your build tools. Now, here is a typical build automation steps. First is download resolve dependencies, then compile. If I talk about interpreted languages, this step won't imply for them, but for compiled languages, there will be a compiled stage. Then you will be running tests. Now, tests could be unit tests. Unit tests implies checking certain parts of your application individually. It could be checking a class or a method and so on. Integration tests requires your application to be running. So you check whether the functionality is working between, let's say, two smaller chunks of the application. So if I'm dealing with a banking application, maybe I want to see whether from the account statement section I can go directly to my account details. So all these things are part of integration testing. Then there are static checks and scans. We have already discussed lint, SAST. SAST is static application security testing. Then you have license checks, you have SBOMs, and we'll see that as we progress with this lecture. At the very last, you package jar var binary, and then there could be one more step, which is deploy. And deploy is same as publish. Here when we are talking about build tools, deployments typically does not mean deploying onto Kubernetes or onto a virtual machines. I'm saying typically because there are build tools, for example even Maven, you can use this to deploy onto a Tomcat server, but that is generally not seen these days. But my point is there could also be deploy, but that deploy is essentially uploading your artifact onto a central repository. Like we have repository for container images, you have repositories for your artifact storage as well. So I hope you have a clear understanding of why we need build tools and what are build tools. With that solid understanding, let's see what I want to discuss next. What is Maven? Maven is Apache's build and project management tool for JVM. Understand, I am not saying Java, I am saying JVM. Now, I told you the source code. When I talk about Java, the source code is converted into JVM bytecode. So any language for which the source code is converted into JVM bytecode, and those languages are Kotlin, Scala, Groovy, and Java. So all these four languages, you can definitely use Maven as a automated build tool for these languages. So Java is a language, JVM is a runtime. So all these languages like Java, Scala, Kotlin, Groovy, they will require a JVM runtime underneath to run properly. And you would have heard these terms when you are deploying Java applications. The machine must have JRE. JRE is Java Runtime Environment, and that's directly related to JVM. So the next point is widely used for Java, Kotlin, and Scala project, but predominantly you will see Maven being used for Java. Interesting fact, you can even use Maven for C, C++, Python, and so on. However, you do not do that because Maven specializes in Java. And why you can do that? Here you see a point. Plugins handle testing and all these things. So Maven has plugins. As long as there is a plugin for C, there's a plugin for C++, you can use Maven for those languages. Having said that, there are specialized tools, specialized build tools that are used for C, C++, Python, and other languages. However, Maven can also be used, but it is not recommended you do that. Then pom.xml is the single source of truth. Now, as we go ahead with this course, we will understand that pom.xml is the single source of truth. So every dependency that your application uses, the details about your application, that is available in pom.xml. Next point is conventions over configuration keep projects simple and consistent. Now, Maven says that we adhere to conventions over configuration. So you as a Maven user will not have to configure everything. We as Maven will give you a proper structure of the project. Now, what is the structure of the project? I mean the project structure, the directory structure. Maven defines that structure, and as we progress we will see that structure. Now I want you to understand, if you would have to configure everything, where source lives, how to compile, how to run tests, where to put outputs, what to name them, which repos to use, and in what order to run steps. That is the configuration you avoid by following conventions, which is why we say Maven is conventions over configuration. Next is plugins handle testing, coverage policies, packaging, etc. Now, If I talk about Maven, there is a plugin that is doing all the tasks for you. Compiling, there is a compiler plugin. If you are doing unit test, there is a Surefire plugin. If you are doing integration tests, then you have a failsafe plugin. If you are doing coverage, then you have Jacoco. Now, coverage is the code coverage. So, for example, if you have 100 lines of code and you are only testing 80 lines of code, then your code coverage is 80%. So you have a plugin that can do that for you, and that plugin is Jacoco. So if you are checking for policies, you can use enforcers. If you want SBOM, there is a plugin called Cyclone DX for that. Now see, I am mentioning a lot of plugin names. As DevOps engineers, if you are in your learning phase, starting phase, do not get intimidated by these terms. As you progress with your learnings, these terms will start making sense to you. And not just when you deal a project that has Java, all these terms will be frequent in your daily language, daily communication. So you will remember these terms. But do not think that there are so many plugins, there are so many tools. It takes time to learn, it takes time for a plant to grow. Keep patient, be at it, be consistent, and all these terms, all these tools will start making sense and you will be able to connect all these. So just be at it. Next is produces reproducible artifacts, integrates cleanly with CI/CD pipelines. As we have discussed before, you define versions at a single place, and that single place in Maven is pom.xml. And as long as anyone is using that pom.xml along with your source code, they will be able to generate exactly the same artifact as you are in your personal laptop. They will be able to do that in the CI server or in their personal laptops, as long as they have your source code and the pom.xml. The next one is Ant versus Maven versus Gradle. Now, Ant is legacy now. It was used before Maven existed. Now, in Ant, you had to configure everything and you have to write your steps manually and so on. So it was configuration. But in Maven, it is conventions over configuration. And then there is Gradle. Gradle provides you flexibility. Now, 80% of the Java projects I have dealt with were using Maven. So I wanted to check what are the stats. So I looked at ChatGPT, and ChatGPT said that 60 to 70% of Java projects are built using Maven, and 30 to 40% of Java projects are built using Gradle. Now, Gradle provides more flexibility and it is predominantly used with Android. So with Android applications, you would often see Gradle being used. But in my experience, I have personally dealt with Maven more, at least in 80% of the Java projects that I have been part of. Now we understand what is Maven. So I do not want to bombard you with another theory part now. Let's go to the CLI and install Maven. So what I will do is I will go to my browser, and I already have created one EC2 instance. This is T3 Micro and it is based on Ubuntu, latest Ubuntu. And let's power this on. So I have not configured anything. I have just created the instance and I've stopped it. Now we will copy the address and SSH into this. So if I go to my terminal, if I run ls here, not this screen, this one. Yeah. If I run ls here, I'm in the .ssh folder. I already have the key required for this instance here, and I will be using this key to log in into my instance. So let's go back to the browser. I will click on connect. I will simply just copy this SSH command. I will paste this command here. I've already given this appropriate permissions, and let me show that to you. If I run ls-la, then you would see that this key that I am using, it has strict permissions. Only read and write are with the owner, and the owner is Varun Joshi, yours truly. So I will just copy that again and I will paste it here. I will press enter, and this will connect me to this instance. Now I would suggest you to rename this instance to Maven like I have done. You can check the command to do that in the GitHub repository. It is hostname ctl can be used to change the host name. I've called it Maven for simplicity. Now let's first install Java. So I will go to my browser, and then here I will go to the GitHub notes for this lecture. I will go to installing Maven here, and then here is the download guide for Maven. I will open it. I will zoom in a little. So we will be installing the latest version of Maven, which is 3.9.11, this one. And it says that Maven 3.9 plus requires JDK 8 or above to execute. Okay, so let's keep that in mind. What I will do is I will right click here and I will copy the copy link address. I will copy this of tar.gz. Now I have specifically chosen to install this into an EC2 instance so that everyone can follow along with me. So I would encourage you to spin up an instance and follow along with me. So I will go to my terminal, and here first I will run sudo apt update, and this will update my index. Once this is done, I will write sudo apt search. I will search for OpenJDK. Now, when I do this search, I see JRE, I see JDK. But in here, what we want to do, friends, is we want to install JDK, not JRE. JRE is Java Runtime Environment, and it is installed when you want to run Java applications. But we are builders, we are DevOps engineers. What we want to do is we want to build Java applications and then run it. So hence, we will be installing OpenJDK. JDK is Java Development Kit. This, along with the JRE, also includes the compiler which we will be using while compiling our application. So let's do one thing. I will be using version 17 for Java. So if I run this, hold on. If I run 17 here, if I add 17 here, then it will tell me all versions of OpenJDK that are 17. So what I want to install is this one, OpenJDK, this one. So what I will do is sudo apt install. I will add that, and then I will add here -y for yes. And this will install Java on my machine. So once the installation is done, I can run java -version to check the version of Java that is installed. So if you see, we have Java 17.0.16 installed. And if I run Java C -version, Java C is Java compiler, it will show me that the compiler version that you are using is 17.0.16. And if you remember, when we were discussing our build tools, we said that the compiler that is often used for Java is Java C, which is why you see Java C was automatically installed when we installed JDK Java Development Kit. Now I want to install Maven. So I could have just written sudo apt install maven -y. Now if I do that, the life cycle of Maven that I install will be governed by apt. Okay, the package manager for my Ubuntu system. But if I install Maven using a binary, like I showed you, we copied the path of the binary. If I use a binary to install Maven, then I own the life cycle of that tool. So the install, the upgrade, the rollback, the cleanup, everything will be done by me manually, or I could automate that process. So often when you are dealing with these external tools like Maven, SonarQube, you would see that these are also installed in /opt. Now /opt is for optional packages. So you would typically see that these tools are installed there. but I will leave that decision to you. I am using a binary so that I can also teach you a few more Linux concepts while we are learning Maven. So I will not run this command, and in this lecture itself, when we move to the last demo, we will be using this command to install Maven. But for now, I want to show you the binary method. And why we are running Java is, why we installed Java first is Maven requires Java. So if you see here, JDK 8 or above is required. So if I copy this link again, I will copy link address. I will go back to my terminal and I will clear my screen for better visibility. I will cd into opt, then I will write sudo wget, and this is the file I want to get. So if I run ls, you see that tar.gz is downloaded. I will use sudo tar-x for extract, v for verbose, z for gzip, and f for files in this file, so that our tar.gz is extracted. So once I run ls, I see that the file is extracted. Now what I can do is I can delete this one because I don't need it. I will run sudo rm-rf, it is Apache, and there is a hyphen bin. I'll press enter and I will run ls. Now this is deleted. I just have this here. So what I can now do is I can cd into Apache. What I will now do is I will rename this for simplicity. So I will use move mv Apache and then I will call it just Maven. And I will also have to add a sudo here. I'll add sudo. I will rename this file. Once it is renamed, I can go into Maven, and if I do ls, I can see that there is a bin directory, and inside bin directory there is the executable that we want to run. So if I go to, if let's say I add bin mvn hyphen version, then I can see the version of Maven. But if I just run mvn hyphen version, this command will fail because my shell will not be able to recognize mvn. Previously it ran because I provided the complete path of my executable. In Linux operating system, if I run SSH works for me. It works because SSH binary is available in the path that my OS is searching for executing any binary. So if I run which SSH, it will tell me that SSH is located in USR bin. And if I echo the path variable, which tells Linux operating system that you have to search these paths in order to find any binary. So if I press enter, you see user bin is here and user bin is also here. So all these paths that are searched by the OS are separated using a colon here. So for SSH, we are searching this, but for MVN is available in /opt Maven, and we don't see that here. So we should be adding that path in our path variable so that when we execute MVN, it can run without us specifying the full path like this. So let's do it. So what I will do is I will go to my user's bash rc file. So I will write vim, and then I want to go to bash rc here, and then once I'm here, I'll press shift G to come at the very last. I will press I to go in the insert mode, and then what I will do is I will write export, and this is how you define environment variables. And then here I will write path is equal to, now what is the path? For me, I do not want to remove that path altogether. What I want to do is I want to append the existing path. So what I will say is, my dear friend, you first take the path that you already have right now, and what I want you to add is I just want you to add /opt/maven/bin in that path, and then I will close this. And once I am done with this, I will hit escape. I will press shift ZZ to save this. Now I will source this file so that it refreshes, and then my shell knows about it. I will write bash rc. Now this is source. Now if I type which mvn, now it is telling me your maven is located here. And if I run maven hyphen hyphen version now, it will tell me the version of maven as well, because now my system recognizes the maven binary, because we have added the path for this binary in our path variable. So if I echo path now, you see I have to put a space here. You will see that opt maven bin is available here. So I hope this makes sense. Now we have installed maven. Now let's go into building our project, the first project that we want to build. I'll clear my screen. I will come to my home directory and ls. I don't have anything here, so I will go to my browser and I will go to my GitHub notes, and then this is the demo that I want to do. I'll zoom in a little. I will open this. Now see, firstly, I told you that Maven is convention over configuration. So what we want right now is we want a structure and a simple source code. So what we will be doing in this lecture is we will be using something that is provided by Maven to us. So if I scroll down, you see that you can create your own first project and you can use this command to do that. So what I will right now do is I will just copy this command. I will copy a format that is much more easy for you guys to understand. So let me go to my terminal and here I will paste it. Now before I run this, I want to explain this to you. MVN archetype generate. Firstly, what is archetype, Varun? Now archetype is project template. Now project template will give you the directory structure. It will also give you the pom.xml. You do not have to write pom.xml from the very scratch. There are multiple archetypes available you can use based on your requirement. So this will provide you a skeleton that you can use for your Maven, and that's pretty awesome. You don't have to write pom.xmls from the very scratch. So we are using a very basic archetype, that is generate. So what is an archetype? An archetype is a project template. So you start with a runnable skeleton. Now what are the fields that we are defining here? Hyphen D can be thought of as part of the syntax. Then we are providing the group ID. Now group ID, we will discuss this in detail much later, but for now just understand it's the reverse DNS of your website. For example, if my website is cloudwithvarjosh.com, then my group ID will be com.cloudwithvarjosh. Artifact ID is my app. Now understand, if Cloud with Varjosh has multiple projects, then how do I identify those projects? Because there is a group under which all those projects reside, but which project I want to use, that is what is provided by artifact ID. So group ID is the, let's say, the grouping, and artifact ID is which entity in that group you want to deal with. Here I'm just saying my app. Then archetype artifact ID. Now this is the artifact ID of the archetype that you wish to use. So like I told you, there are multiple archetypes available, and the artifact ID for that one is Maven archetype quick start. This is the ID that we wish to use. Now there could be multiple other archetype artifact IDs which would result in a different POM file or a different source code, but the source code that we will be using is part of the archetype quick start. Then this is the version of this 1.5, and this is pretty much self-explanatory. Interactive mode is false. So I will press enter, and once I do that, this will create a project structure for me. So if I press ls now, you see that my app is there. Now I will cd into my app. and I'll clear my screen. I'll press ls. You see two things here, src and pom.xml. So let's run tree command. Oh, I don't have tree installed, so sudo apt install tree hyphen y. Now what this will do is this will install tree, and tree is a fantastic utility that will tell you the directory structure. So if I clear my screen, I run tree here, it will tell me that this directory has pom.xml, and this also has source, and source has this hierarchy, and test has this hierarchy. So firstly, I want you to know that you as DevOps engineers will not be writing pom.xml from the very scratch. I hope that relieves you a little. And then the source part also, it is not you who will be writing this src directory. This contains the actual code. So main here contains the code, and test here holds the tests that will be performed. Here we have created it, but in actual production applications, these things will be part of your scm. So when I say your pom.xml and src will be in scm, the first thing that should come to your mind is these files should not have any credentials, any secrets, any keys, because even if you are in a private repository, you should never commit your secrets onto scm. So first thing is you will be storing these in your version control. So it could be your github, gitlab, or any other version control system. Now we have briefly discussed about pom.xml. Pom.xml is the main maven file for your project. It is the file that is the single source of truth for maven. It tells maven your project's identity, libraries, dependencies, build steps. Maven reads this file to build, test, package, and deploy your app the same way every time. So understand, this file is extremely critical. So let's do one thing. I will cat into pom.xml. So this is as expected in XML format. So I want to explain this file to you line by line so that you can easily understand what happens in pom.xml as DevOps engineers. Now you would be thinking, Varun, if we are not writing this file, we do not have ownership of this file, then why should we understand this? You want to understand this because at times most of the build failures will be directly related to pom.xml. Essentially, if your build is failing, there is something tricky or something going on in your pom.xml. So until and unless you as DevOps engineers understand pom.xml, because the CI CD ownership is with you, you are the one who will be integrating different plugins in the pom.xml. Your developers will be writing the most of it. But if you are using a plugin for security testing, if you are using a plugin for something else, those plugins would be added by you in the pom.xml. So you want your pom.xml to be error free, and you as DevOps engineers can only ensure that once you understand the pom.xml file to begin with. So here it is in a black and white format. So what I have done is I'll take you to Visual Studio Code. I have copied this pom.xml exactly like you see here to this screen so that I can explain the pom.xml. Now before I start explaining pom.xml, I feel it is imperative you first understand XML. So I will just take 5-10 minutes to tell you basic XML, and then we can start with pom.xml. So XML, JSON, and YAML are all text-based format for structuring and exchanging data. Though XML is a markup language with tags. Now, what are tags? We'll see that later. while JSON and YAML use key value style structures. And you are well versed with YAML because most of the DevOps tools use YAML. And if you have done CKA and if you search my channel, you can see JSON path lecture. If you don't know JSON, you can learn more about it there. But for now, we know what XML is. Now let's understand this structure. Now XML uses something called elements. So what you see here, this is an element, this is an element, this is an element. Then Varun, what is an element? Element is something that starts with a tag and then closes with a tag. So for this element, this is the starting tag and this is the closing tag. For this element, this is the starting tag and this is the closing tag. Now closing tag has a forward slash in it. That is how you identify it. Now this is one element. Varun, why is this one element? So see, this element starts with project. This is the starting tag and this ends with project, which is the closing tag. So entire this is also an element. Then Varun, how do I differentiate? So project here is a parent element, and then whatever you see here, the indentation, follow the indentation, this, all of these are child elements. Similarly, if I talk about these properties element, then whatever you see inside it is child element of the properties parent element. So this is pretty basic, and you would have seen something similar when we talked about YAML or JSON as well. You see, this starting tag is simple, but this starting tag has these things as well in them. Now anything that is there in the starting tag, these are called attributes. Now this project tag has 3 attributes. Now you do not have to understand this deeply because it's just touch and go. You will rarely be playing with these things are pretty much this constant in pom.xmls. I'm just telling this to you for your understanding. And what you see in here, this is called text. So this element has this text under it. Now this is all you want to know about XML. Now with that understanding, let's start discussing pom.xml. Now this is the basic structure that you would see. This is the root element. Whatever you see at the very top, this is called the root element, and that's understandable. This one is the root element. And then you have these things. Model version will pretty much always be 4.0.0. What I have done is I have added comments in this XML, and the format in which you add comments in XML is this. So any comments that you want to have can be under this. It's pretty funky, but that is what it is for you. So you have to add comments like this, and you can see here POM model version fixed at 4.0.0 for Maven 3 and 4. So that's why I said it will pretty much always be 4 in whatever projects you are dealing with. Then the most important part is GAV, and we call these GAV coordinates. So when we talk about any location on our mother earth, we talk about coordinates. So if you want to reach there, these are the latitude and longitude, and if you reach there, you will reach that specific destination. So essentially, coordinates are address for a specific location on earth, right? Similarly, if I talk about GAV coordinates in Maven, these uniquely identify a dependency or a project. We will dissect this definition as we move ahead. Now, GAV is used to uniquely identify a project or dependency, whether it is in your local or remote. Varun, what is local and remote? So understand, if you talk about container images, at times the container images are available in your nodes, and at times they are available in image registries, and then you pull it from there, correct? Same concept here. You can have your artifacts or your dependencies locally, or you can have them in a remote location. So GAV is uniquely identifying your project or dependency. But Varun, why are you using project and dependency interchangeably? Understand, my Maven project could depend on another Maven project, and if my Maven project depends on another Maven project, then how do I reference that another project? I reference that using GAV, because I know for a fact that these GAV coordinates are unique for any project or any dependency. For example, if there is a MySQL dependency, it will have a group ID, it will have a artifact ID, and once you provide these things along with the version, only then your Maven instance will be able to resolve that or fetch that. So if you do not provide version for your dependency, for example, then Maven will not fall back to latest, it will not fetch it. So providing these coordinates, GAV coordinates, project coordinates, are of utmost importance. So now that we understand this, let's dissect G, A, and V. So here the group ID we have already discussed, it's a reverse of your DNS. So here the example that we are using, it's com.mycompany.app. Then artifact ID is module name. Now see, understand it this way. Your organization could be dealing with multiple microservices, correct? In that scenario, what you can do is, let's say you are talking about application 1. So let's copy this so that you understand it in a nice way. So I will copy this, I will come here. Okay, I'll paste it here. Let's take care of the indentation as well. Let's do one thing. Let's call this com.cwvj app. Now this is for app 1, let's say. Now if this is for app 1, app 1 could be consisting of multiple microservices, and then I could name that artifact ID app 1 slash hyphen payments, and then another one I could name app 1 hyphen orders. I want you to clearly understand that when you are dealing with an application, your application could be a single application that only has one pom.xml like this one, or you could be dealing with an application that has multiple pom.xmls. Why multiple pom.xmls? Because each microservice will have its own pom.xml. Like I showed you here, if you are dealing with this, then you will have one microservice with this, another microservice for orders, another microservice for let's say wish list, and this holds true not just for microservices but for also your pom.xml. So the number of microservices is directly proportional to the number of pom.xmls that you have had. Now the group ID, this depends on how you want to keep it. Maybe you have it for per application, or maybe you have it for your entire application stack. If your applications are not microservices, then you could have just app here, and then one pom.xml could be for app 1, another pom.xml could be for app 2, and so on. So create that mental picture in your head. So now that we understand both of these, let's talk about version. Version is simply the version of your application. But Varun, why do I see a snapshot here? Now versions can be of two types. They can be releases or they can be snapshots. When we are talking about releases, think of them as production. They are immutable, they do not change. But when I talk about snapshots, snapshots are, that is, work under construction. So the development is still ongoing whenever I am talking about snapshots. So in essence, when someone is developing it, understand that they will be pushing it as well. Then how do I ensure other developers that are using this snapshot, they always have the updated snapshot with them? Now that something is governed by something called update policy. So I'll take you back to the GitHub repository, and if I scroll here, you see snapshot versus releases. The refresh rules for these snapshots are defined in update policy. Now that can be always, daily, you can specify an interval, or never. If you build your application at a regular interval in a day, then I would suggest you to choose always, and daily if you just build once a day. And these things are subjective. I will let you choose what is best for your use case. Now let's go back to our Visual Studio Code. Now let's discuss these. Now name is a display name. Now this is typically same as the artifact ID, but you can have a different name like this. What it will do is this name will appear in all your reports and logs. So ideally you should keep this same as artifact ID, but if your artifact ID is not descriptive enough, then you can have a different name here. URL. Now this does not necessarily mean a public facing URL. This URL could point to your repository, or it could point to your documentation, or it could point to the wiki. So if you are dealing with, let's say, a microservices design, this pom.xml belongs to a payment microservice, then within your organization you will have the link of the private, let's say, GitHub repository that holds the code and pom.xml for this specific microservice. Now let's scroll down. What you see here is properties. Maven properties, build time placeholders, not OS environment variables. Now do not mix this with the concept of environment variables, but they function kind of in a similar way. So what happens is, whenever you are defining your dependencies, you have the right to not define the version in the dependency section, but ask the dependency section to refer the properties section when they want to check the version of a certain dependency. Now Varun, why is this useful? So imagine in production implementations, your pom.xml could have hundreds of dependencies. It is futile. It is not worth your time to search for those dependencies and maybe change the version. What you can do is you can directly come to the properties section, check the version that you wish to change, and change it here, because anyway the dependencies are referencing the properties section to fetch the version. So let me show this to you. I'll go to the browser and then I will scroll down. Here you see properties, and you see what I have done is these two properties are built in. So for example, there is no dependency that is referencing these properties explicitly. Implicitly under the hood, Maven is using them. But for you to understand, what I have done is I have added two more lines here. You see, I have added two more properties. One is Spring Boot version 3.3.4, and then there is a JUnit version which is 5.11.0. Now, how do I reference this in the dependency section? If I scroll down, you see in the version section, I want you to clearly understand that whenever we are talking about a dependency or a project, what is the thing that uniquely identifies them? It is the group ID, the artifact ID, and the version. This is the gov coordinates. So keep this in mind. Version, supplying version is important. If you do not specify any version here, then this will fail, because Maven will not automatically choose the latest version. It will just fail. So you must provide the version of the dependency that you wish to use. So here we are saying, when you want to check the version for this dependency, you go to the properties section and check for Spring Boot version, and here it is, Spring Boot version. If you want to check the version for this dependency, you go to junit.version, and here is junit.version, and it will pick 5.11.0 based on what we have defined in the properties section. So you would often see that properties section is used heavily in production implementations. Now let's go back to our Visual Studio Code and understand what is dependency management and dependency. So right off the bat, I want you to clearly understand that dependency management is not downloading any dependencies for you. It is just there to tell the version of the dependency that you have not specified in the dependency section. So for example, if you have not specified the version for a dependency in the dependencies section itself, like you see here, there is no version here, version tag here, then it will check with the dependency management section. So that is what dependency management is doing. So in a single line, so dependencies, what actually gets pulled into your project, dependency management is the version rule book used only when dependency doesn't specify its own version. So here you see both of these dependencies, they have not specified its version, which is why dependency management section is referenced. Now you might be thinking, Varun, I see JUnit Jupyter API here and I see JUnit Jupyter params here, but I do not see an artifact ID with a same name. I just see that you are referencing something called JUnit BOM. You are importing something called JUnit BOM. It does not have these names. Then how will this work? Here I want to explain the difference between SBOM and Maven BOM. So you see it's a JUnit BOM here. SBOM is something that we discussed in our Jenkins lectures, CI/CD lectures, where we learned that SBOM is software bill of material. This will hold everything that your software is using. Any library, any dependency that your software is using is part of SBOM. And SBOM is good because it tells you that these are the libraries that you are using, and some of these libraries require licenses. So you may have to pay someone to use these libraries. So SBOM will tell you things like this, whether there are any vulnerabilities in the dependencies that you are using, in the libraries that you are using. So SBOM is good for that. Do not confuse SBOM with Maven BOM. Maven BOM says that whatever I am downloading, this has everything about that specific thing. So here JUnit BOM will have the version information. I'm not saying it is a dependency, it is downloading some dependency, it is downloading a dependency with a specific version. No, I'm saying JUnit BOM will have the versions of everything JUnit. So here we are using JUnit Jupyter params, and here we are using JUnit Jupyter API. So this JUnit BOM will have the versions of all these dependencies, and we know for a fact if a dependency is not defining a version, it will not be downloaded. What it will do is this dependency will check the JUnit BOM and it will find the version that is to be used for JUnit Jupyter API and the version that is to be used for JUnit Jupyter params, and it will use it. So a BOM is essentially a collection of all the versions that are specific to that something, and that something here is JUnit. Now another thing I want you to understand is the type is POM and here the scope is test. Now this type is fine, a POM, we are calling it POM because it just has the version information. The default is jar here type for dependencies or for dependency management, but we are saying POM because this JUnit BOM will just hold the versions, not the actual dependencies. We have discussed this at stretch. Okay, now the scope is just import and the scope here is test, and we will now see what scope means. So let's go back to our GitHub notes, and again I would encourage you to go and read the GitHub notes. Whatever I am discussing is there in the GitHub notes. You see here dependency management BOMs. It is the version rule book. So if I scroll down, we have already discussed these. Now I want to discuss scope. Now see, When you are building a project, you will be performing different things. You will be compiling, you will be testing, you will be running the application, and so on. Now you don't want that whatever was generated during the test should be available in at runtime or during compilation, right? Because it is unnecessarily increasing the attack surface, because you must choose the narrowest scope that fits to reduce size and attack surface. You choose the scope that is needed for that specific dependency. Now, what it is? A switch that defines which class paths the dependency appears on. Bundling depends on project packaging and plugin. So let's see what I mean by this. Let's see this with an example. So if I am using a dependency called JUnit Jupyter params and JUnit API. Here I have defined the scope as test, which is a good practice because I don't want this dependency to be available at runtime. I don't want that. And if I would have not defined this scope, the compile scope would have been taken, and in compile scope the dependency is available in the compile part as well, in the test part as well, in the runtime part as well. I don't want that at all. I just want the dependency to be available for the stage it is needed. If I am performing testing, then it should be only available for the test class path. If I scroll down, I would again encourage you to read all of these. Now let's discuss the last part here. This last part is about plugins. Now, when I talk about Maven, it is plugins that are doing the actual work for you. So be it your build, be it your compile, test, or package, whatever work is being done is done by plugins. Now in this section, in plugin management section, you just pin the version of plugins that are to be used. So you see, if I'm talking about compiling, then the version of the compiler that should be used is 3.13. If I'm talking about tests, Surefire plugin, the version is this. If I'm talking about packaging to jar format, then the plugin that I want to use is this, and the version that should be used is 3.4.2. As simple as that. Now you have a good understanding of pom.xml. With this understanding, let's see what I want to discuss next. Now next is another theory session. I'm sorry for that, but see, until and unless you understand the theory, the demos will not make sense. So we will have to do that as well. So I'll scroll down, and I want to discuss build lifecycle, phases, plugins, and goals. Maven follows a life cycle made of ordered phases. At each phase, plugins goal perform the actual work. Okay. Now, like I told before, plugins are the ones that are actually doing all the legwork for you. So life cycle is divided into three parts. Okay, so if I talk about life cycle, there is a default life cycle, there is a clean life cycle, and there is a site life cycle. Now each life cycle has different phases. This one has 23, this one has 3, and this one has 4. So if I take you to the documentation, if I go to GitHub documentation and then I scroll down, so there are 23 phases in the default life cycle, but we only discuss the ones that are mostly used. So if you want to see all the phases, then you can refer this link, and this will show you all the phases that are there in the default life cycle. So there are so many phases. What I want you to understand is, let me go back to draw.io. If you run the test phase, it will also run the compile phase and validate phase. If you run the deploy phase, it will run all the phases that are before deploy. So it works like this. If you run verify, then it will run all these phases before verify. So it is, if you go to the documentation, if you run test phase, then all these will be run by default. So all the previous phases of the phase that you are running will be run when you run a phase. I hope that makes sense. Now, first phase is validate. Now, again, I want you to know that life cycle and phases, these are logical concepts. Okay, these are just concepts. They are not doing the actual legwork. Actual legwork is done by plugins, and we'll see how that works. So this is self-explanatory. Validate phase, it will validate your pom.xml. Compile phase will compile your main source code into .class. Then there is a test, it will run tests. Package, it will package it into jar var. Integration test will execute integration test. Verify, run post package checks, and quality gates. Install, these two are important, and these are relevant to the architecture that Maven uses for storing information. Now, we have not discussed about repositories yet, but for now, just understand that there could be a local repository and then there could be a remote repository. With that understanding, let's understand these definitions. Install will publish the artifact. Publishing the artifact implies uploading the artifact to the local repository. So for example, if I have installed Maven onto my Ubuntu EC2 instance, then it will just upload or publish the artifact in the local repository, and where that local repository is, we'll see that later. But for now, just understand, install part deals with local repository and deploy part deals with a remote repository. So in deploy part, you publish the artifact to a remote repository. Then we talk about the clean lifecycle. As the name implies, it is required for cleaning. Now, Varun, why do I need cleaning? And you need cleaning, and this cleaning is relevant to the artifact that is being generated. Now understand, when you already have the source code, you can use Maven commands to generate an artifact out of that. And once that artifact is generated and you have done the upload of that artifact, you don't want that artifact to stay there, right? That can be deleted, because if you want that again, you can again generate that artifact because you already have the source code. And how this is all done, we will see that. But for now, understand that cleaning deals with cleaning of the artifacts that are generated. So artifacts as in .jar or .var, and it is specifically also telling you the directory. So right now, when we saw the project structure for my app, you saw there was pom.xml and there was src. So if I run ls, you saw pom.xml and src. Whenever you do a build, whenever you do a packaging, for example, you would see that a new directory gets created called target, and this target directory holds the artifact for you. So that is what we are saying here. Remove outputs from previous builds. Now there are certain tasks that you can perform pre-clean, and then there are certain tasks that you can perform post-clean. So these are just referencing them. Then there is the last life cycle called the site life cycle, which has 4 phases. Now this deals with the site documentation, about the site generation. So there are different phases here: pre-site, site, post-site, site deploy. I have written about them in the GitHub repository. For us DevOps engineers, these 2 phases are of utmost importance, though we should also know about this. So for now, I will let you read about this, and let's see more about these phases. Now, what did I tell you? These phases are not the ones that are actually doing the legwork. So if I go to my terminal and I clear my screen, I will just run Maven validate. Okay. And I'm running Maven validate because validate is a phase. Understand? I am running a phase. I'll press enter, and this will validate my project structure and my pom.xml and will give me an output, which is okay. And as you know, if I now run Maven compile, it will run the compile, but it will also run validate because the previous phase automatically gets executed. So this is understandable, but I also said that these phases are not actually doing any legwork. Legwork is actually done by your plugin. So let's go to the GitHub repository and I want to show that to you. If I scroll down, yeah, this is the chart that I want to show you. If I talk about the default phase, so whenever you are writing mvn compile, for example, then behind the scenes, the plugin that is being used is Maven compiler plugin. And now I want you to correlate. So if I go to my Visual Studio Code and if I scroll down, we defined the version of Maven compiler plugin as well here, 3.13, just for your information so that you can correlate these things. So if I go back, whenever I'm running mvn compile, under the hood this plugin is being used, and a plugin can have multiple goals. When you run mvn compile, it is the compiler plugin's compile goal that is being triggered. So this is the only thing that you want to take away from this. When you are running a phase will be supported by a plugin, and that plugin can have multiple goals. And when you run mvn compile, the compiler plugins compile goal gets executed. So a plugin, a tool Maven can use, and that plugin could be compiler, test runner, packager, deployer, and you have seen these plugins here, right? Surefire plugin. Now if it is Maven compiler plugin, it will be just called compiler. If you have Maven Surefire plugin, it will just be called Surefire for simplicity. And if I come here, if I run, let's say, mvn test, or let's say mvn package, if I run mvn package, then Maven jar plugin gets used, and the jar plugin's jar goal is invoked. Again, if you are running mvn test compile, then also the compiler plugin is used, but this time compiler plugin's test compile goal is used. So understanding this is very important. When you are dealing with plugins can have multiple goals, and based on which phase you have run, that goal is executed. Now someone is thinking, we have just run mvn compile, so let's run this command as well. So let me go here and I will run ls, and let's run mvn compile. And if I run mvn compile and press enter, you know that when compilation runs, a previous phase automatically gets run, and that previous phase is validate. So if I go to my diagrams, if I'm running mvn compile, we know validate automatically runs. And if you have to see the extensive list here, if I go here, if you run compile, all of these things are getting done. Okay, but we have not explicitly mentioned them because we are only dealing with the most used phases. But understand, when you are running compile, all these are also getting executed. But the interesting part that I want to show you is, if I go to this, if I run mvn compiler compile, then only compilation will be done. The previous phases will not run. Why? Because I am directly invoking a goal. I'm directly executing a goal. I'm saying just compile. But if you run mvn compile, it will also validate. It will also run all the other phases like you saw before. So what I will do is, if I run ls now, you see there is a target folder created. So if I run mvn clean now, what it will do is, mvn clean is a spell error, mvn clean, it will just delete the target folder. So if I press ls, it is just showing source again. So let's run mvn compiler compile, and if I run this, this will not perform any validation. This will just run this call, and it will be evident from the output you see. And if you see this output, just compiler is here, right? And if I scroll above, if I see the output for mvn compile, you see resources is also there, because it is explicitly showing that. If I go to my browser, if I go here, then you see there is something related to resources that also runs when you run the phase. But this time we only ran a goal, which is why you only see compile here. So understanding these nuances are important, because they somehow decreases the time your pipeline takes to run. For example, if I were to run mvn install, then all these phases will run. But if I am sure that mvn install will work just fine, then why not just run a goal with a plugin that will just publish the artifact to local repository. So understand why there are features, why there are functionalities available. You would be using them based on your requirement. So for example, if you run mvn deploy, it will run all the previous commands. But what if you run mvn deploy, it will only deploy it, it will not perform all these steps. So keep these things in mind. Now that we have this understanding, I want to take you back to a demo. So I will go to my terminal, and here we have already seen few commands. We have seen mvn validate, we have seen mvn compile, and now what I want to show you is mvn. So first let's run tree. I'll run tree, and this shows me that target has classes, and you see this hierarchy. This is done based on whatever was there in our pom. So app my company com, and if I go here, app my company com. So this directory structure is taken care by maven itself. We did not have to do anything there. So here what I will now run is, I can run java. I want to run this application, so I will run java class path. Now where is my class located? So I know that it is target, and in target we have classes, and inside classes what I want you to do is, I want you to run this com dot my company dot app, and here I want to run dot app, this one. Okay, I am specifying a target, and then I will press enter, and there is a spelling error, it should be company. And if I press enter, you see hello world, and that is what this application is supposed to do. And what I can also do is, I can run mvn package. And what will mvn package do? See, we do not see a .jar file yet, we see a .class, because what we ran before was mvn compile. What mvn compile will do for you is, it will change your source code into .class. But what mvn package will do is, we learned it here, package will convert your source code into jar, var, or whatever format you define. For us it is jar. So if I run mvn package, it will create .jar file for me. So let's run this, and once this is run, I'll run tree again. And you see in the target itself there is my app one. You see what format this is adhering to? We have defined this in our GAV itself. So if I go here, this is the 1.0 hyphen snapshot, 1.0 hyphen snapshot, and this my app is coming from here. I hope all this is making sense to you. Now if I want to run this jar, what I can do is, I can write java hyphen cp, and this time my target is, previously our target was classes, but this time my location of this is in the targets directory. I want to go to my app dot jar, and then I will just specify the same thing, com dot my company dot app dot app. Now this might feel a little off to you if you are not from development background, but whenever you are running a java application, this is how you run java application. So it is, once you start working, you will understand these things. If I press enter, this is saying hello world. Now let's run mvn install. Now, what MVN install would do is it will publish the artifact onto your local repository. But Varun, where is the local repository? And it is here. It is pointing to your local repository. It is saying that whatever artifact you have generated right now, that artifact has been published onto the local repository. If I would have run mvn deploy, then it would have published the artifact onto a remote. But have we defined the remote yet? We haven't, right? So if I here run ls and I supply this, then of course you would see that there is a snapshot file there, and along with the snapshot it also has a .pom and some .xml metadata as well in this location. So for now, mvn install we have seen. Now let's run mvn deploy. Mvn deploy will fail because we have not defined a remote where this artifact could be published. Now I want to show you a few more things. So mvn clean, as we know, will clean up our target directory. So if I run ls, I don't see target anymore. I usually in projects what you would see is two phases are called simultaneously. So mvn clean will be called first and then install will be called. So what it will do is it will first clean the target directory and then it will run mvn install. So this is a step by step process. First mvn clean will run, then mvn install will run. And we know for a fact that mvn install will again recreate this slash target directory. So if we run this, then if I press ls, you would see that slash target is again created for you, and mvn clean, as we know, will again remove this. Now we can also run mvn site. This will generate the site data for you. And if you run tree after running this, let's first run ls, then I will run tree so that you can see what all things are generated with the site. So ls, if I do tree, then you see in the target the site data is also created for us. Now I will let you explore this. Now that we have gotten this understanding, let's go and understand repositories. So if I go here, what is a repository? Repository stores artifacts, forms and metadata. And when I showed you the local repository just now, you saw that there were files with extension .pom, there were files with the name metadata in it, and there were also artifacts. What were the artifacts? The artifact that we saw was a .jar snapshot version, and that is what our pom was intended to generate. So repository is a place where we store artifacts. That point is clear. On the right of your screen, what you see is a local repository and then remote repositories. Local repository is maintained in the machine that has maven installed. So in my demo, my ec2 instance had maven, which is why a local repository was there, and local repository is in the .m2 directory that we already know from our previous demo. But Varun, why are remote repositories needed? Now understand, when you are downloading certain dependencies, your application may require dependencies that are not available within your machine, which are not available in the local. And why they are not available in the local? Understand that the local repository is supposed to cache whatever dependencies are needed by your project. So first the dependencies must be fetched from somewhere remote, and once they are fetched, they can be cached into your local repository. Your local repository is there to speed up your builds. Now you might be thinking, what are the examples of remote then? Then remote could be maven central. Now maven central will hold the most popular, public dependencies that can be leveraged by anyone. And similarly, your project could also be using that, the example that I gave you before. For example, if I'm using a library that has the logic for calculator, then that logic can of course be found in maven central. So let me show that to you. So if I go to my browser and I write Maven Central here, then I should see MVN repository central. So yeah, this is the repository. So if I search for, let's say, MySQL, then I will see MySQL connector is this one. Let's see MySQL connector for Java. So let's click here. And if I click here, it is saying that category is JDBC drivers. And if I go to any of the versions that I wish to use, let's go to 8.0.33, then it will tell me how can I use this dependency. So if I add this in my pom.xml, then it will fetch this specific dependency from Maven Central. Now, will it always fetch from Maven Central? It depends on what are your precedents. Now, precedents we will see in a little while, but for now, I hope you got the idea. So let's go back here. Now, remote can be of multiple types. I will tell you the most popular remotes that I have seen. First is Maven Central. You pretty much will always have that. And this is something that is configured in your SuperPOM. What is SuperPOM? We will see it in a little while. Then you have vendor repos. Let's say you are using a custom application. Now, custom application will also have, let's say, custom dependencies, which that vendor has specifically created for that application. Now that you are using that application and building that application, you would want to use those dependencies as well. So such dependencies are fetched from vendor repositories. You could be using vendor repositories or could not be using vendor repositories. It depends on what is your use case, whether you are using a custom application, building a custom application whose POM fetches dependencies from somewhere remote. So that is one option. From somewhere remote, that is a vendor repository. Then the third type you would see is company managed, and this is something that you will see 100% of the times when you are dealing with production implementations. Company managed repositories are the repositories that are company specific. So for example, you know that these 5 dependencies most of my project use, then you will upload those dependencies in your company managed repository. Now, company managed repositories may have access to internet or they may not have access to internet, depending on how tightly governed your environment is. If, for example, your company managed repository doesn't have access to internet, then all the dependencies that are required by your application, you will pre-download those dependencies onto your company managed repository. Now, what are the examples of company managed repositories? You would have heard of Sonatype Nexus. Sonatype Nexus is a popular choice. Then another popular choice is JFrog's Artifactory. If you are onto a cloud provider, you could be using the native repository provided by your cloud provider. So in summary, repositories can be categorized into two: local and remote. Local is something that is available in the instance where Maven is running, and local will cache any dependencies that were downloaded from outside so that your next builds can run in a speedy way. So caching enables faster, repeatable offline builds. Then remotes can be of 3 types in general. There is central repository that is configured via SuperPOM. Then you have vendor repos. Now these are optional depending on your sort of deployment, but you would pretty much always see company managed repositories. Now that we have this basic understanding, let's go to the next slide so that we can deeply understand what a production grade architecture looks like. Here I have just given you the definitions of local and remote. Let's see how production implementations may look like. So this is the production flow with match all mirror. So images on the left can be ignored for now. Let's concentrate on this diagram. Like the previous diagram, we have the same number of components. There also we had a total of 4 repositories. Here also we have a total of 4 repositories: 1, 2, 3, and 4. Now this one is local. What we have configured here is we are telling our Maven, for any dependency that you want to resolve, you reach out to the mirror and mirror will know what to do. So for example, let's say I'm fetching a dependency. If mirror has it, mirror will hand over that dependency to Maven. If let's say mirror doesn't have it, then you as the administrator of this mirror, would have defined how to get the dependencies that you do not have stored. So that mirror could be reaching out to vendor repos, or it could be reaching out to central repository to resolve that dependency. But understand, in this scenario, your mirror must have means to resolve that dependency. Now, why I'm using the word must is because of this asterisk. Let's see why this matters. So what we are saying is, any request that is generated, you just send it to the mirror maven and mirror will help you out. Now, mirror, if it has, it will give the dependency, otherwise it will fetch it from here. But if you have not configured your mirror to fetch the dependencies from central and vendor repos, then your command will fail. Maven will not reach out to Maven Central if you are using an asterisk here, because what you are essentially telling Maven is mirror has all my answers. You reach out to mirror and then mirror will reach out to the required repos to fetch the dependency. But if you have not configured your mirror like that and you are using asterisk, then the dependency resolution will fail. Now I want to explain two more things. There are two things. There is downloading dependencies and then there is uploading artifacts. So for downloading dependencies, we just learned what the architecture may look like. But what about uploading dependencies? Uploading your artifacts. How do you do that? And you might be thinking, why do I want to upload my artifacts, Varun? You want to upload it because other projects could be using your artifact. Maybe the project 2 that Varun is working on requires the artifact that project A has generated. Again, understand that these artifacts, what are these? These are jar files, these are war files, these are ear files. And what are these dependencies? These dependencies are also these jar files, these ear files, these war files that your project might need. So keep your mind open to understand these things. So the answer to why publish, and why publish is when you run mvn deploy, your artifact is published onto a remote repository. So why publish? You publish jars so that other applications, other services, or other teams can use them as dependency in their project, and they can reliably pull them from remote repositories. And the concept is same as container images. You build once, push the container image to a container registry, image registry, and anyone who needs can pull and use that image. Similarly, we have the concept of artifacts here. Artifacts are uploaded and anyone who wants to use that artifact can use it. Now, upload could also be of two types. You have two versions, release and snapshot. So both of these repositories, they are contained in the Nexus or JFrog itself. I've shown them outside so that you can bifurcate it easily. So any release version is added here, any snapshot version is added here, and these both are part of this your Nexus or JFrog itself. So now let's move to the left and see how these things are configured. Firstly, I want you to pay attention to this part. What I'm saying here is, in home directory of the user, you have m2 folder and there you have settings.xml. So if I go to my terminal and I go one step back, and if I hit ls-a, you see there is an .m2 folder. If I run ls on .m2 directory, I don't see a settings.xml. So you will have to create this settings.xml. Now another option is this setting. If I create settings.xml here, that will be specific to this Ubuntu user. But what if I want a global configuration? Firstly, I wouldn't suggest having a global configuration, because if you have a global configuration, then all your users can access your global configuration. So for example, right now I have user Ubuntu, but next, let's say I create a user Ramesh. That user Ramesh will also have access to this settings.xml, and you might not want that. Hence, what I suggest is only your Maven user or your CI server should have access to settings.xml. So you create this onto the user that you will use for Maven. So here our user is Ubuntu, which is why you see in my diagram, I have created this settings.xml in the home directory of Ubuntu user. And I have defined a mirror here. So what I am saying is I have an asterisk here. Anything, any dependency you want to resolve, you send it to the mirror, and the mirror will have the information on what to do with that. Then if you see my pom.xml, in pom.xml, I am defining my deploy targets. I am saying that if you want to deploy releases, you go to Maven releases, this one, nexus.example.com repository Maven releases. If you are deploying snapshot versions, then you go to the same path, but at the very last, replace releases with snapshots, and you will be storing them here. Now, understand that pom.xml will be part of your source control. So it will be pushed onto your, GitHub, GitLab, and your version control systems. Hence, you do not want to store credentials into your pom.xml. So the recommendation is you store your credentials in your user, in your user's home directory that is supposed to be used for Maven. And that is exactly what we have done here. If we would have defined this globally, then all the users would have access to this file, and we do not want that. Hence, I recommended have this details, have the mirror and the credentials for the remote repository, for your mirror repository in your settings.xml, which is part of the home directory of the user that is used for Maven. I hope this is clear. Now I want to go to the GitHub repository and show you a few more things. So if I go here, this is what we have already discussed. Here you have what is a repository, and here you can see, and I have given all the recommendations that you can use here. Mirror, declared remote, what is mirror, and we have defined that here as well. Deploy versus resolve, whatever we have discussed just now, I have defined it here as well. Now see, this is the picture that I have in the diagrams. A, B, this is also what I have in the diagrams. Now this is C. So if you are not using match all mirrors, then you would supply your remotes like this. You have defined the first remote is this and second remote is this, and they are checked in this order. Now you see, I have mentioned the order here. Why this order matters? So firstly, whenever a dependency resolution is taking place, your Maven will first look at the local. If it is not in the local repository, then it will go to mirrors. Now, if you have configured a specific mirror, now you would configure a specific mirror if you also intend to define your remotes like this. Okay, then it will go to the mirror, and then it will go to the declared remotes in order. And if none of those have those dependencies, it will go to central, Maven central. But the scenario where your mirror has an asterisk, this order is local will go to mirror. If mirror doesn't have an answer, it will not go to Maven central automatically. You should configure your mirror in such a way that if mirror you don't have it, then the dependency can be fetched from the vendor repos or from the central repository. So I hope that makes sense and you understand this order part too. Now let's go to the browser and see what I want to discuss next. I want to discuss super pom and parent pom. So firstly, super pom. Now we have been using archetype to generate our source code and the structure, but who is providing this structure? Who is providing the access to the Maven Central? We have not configured our Maven to reach out to Maven Central, but it is automatically downloading dependencies. As we have seen, we have not defined any reporting structure, or we have not defined any sensible defaults. So all these things are coming from a super pom. Every pom.xml you write implicitly inherits from Maven's super pom. So it can be thought of as a default pom bundled inside Maven. It defines global defaults, for example, all of these. So now you know how important is super pom and why it is used. But what is parent pom? So before defining parent pom, I want to give you an example. Let's say you have an application that uses 10 microservices. Now, if you have 10 microservices, you would have 10 pom.xml. Now, let's say each microservice that your application uses has 50 dependencies. So 50 dependencies implies you have a total of 500 dependencies. And if 50 dependencies per microservice, let's say 30 of those dependencies are same for all the microservices. Now understand, GAV parameters coordinates are must for all your dependencies. Now, does that make sense to define all the versions for 50 dependencies that are used across your application? In 10 microservices, you will have to have, each dependency will have a version number. Not sane, right? And even if you have, what you can also do is you can have a properties section in your pom.xml, and that properties section can define the version, and then your dependencies can refer that also works. But if you have to change any version, let's say if you have to change the version of one of the dependencies, then you will have to make changes at 10 different places in 10 different poms. That's understandable. But what if I could centralize every version that is needed into a central file called parent pom? That is what parent pom does for you. parent pom will Parent pom can be used as a version repository, so it can hold all the versions that are needed by your dependencies, and your child poms, all those 10 microservices, can refer to this parent pom to check the versioning information for any of the dependencies. Now, how that makes your life easier: if you have to change a version, you just change it in the parent pom, and the child poms can automatically refer that parent pom. So let's see how that works. And parent pom is just another pom you own that child projects inherit from. In production, it is used to centralize dependency management, like we just saw, shared versions bombs. In plugin management, set common repositories, properties, enforce organization wide rules. Maven enforcers. These are advanced concepts. I'm not discussing them, but as you progress with your Maven learnings, I will let you explore these as you move with enterprise grade projects. Now, we have understanding of parent pom and super pom. I want to show you the structure of parent pom. So here is the parent pom, Cloud with Varjosh parent. So if I go to my child pom, I am saying that Spring Boot starter, all your versions come from parents Spring Boot BOM. So as we have discussed before, BOM here is the type POM, and we are fetching this, and this will have the details about all the versions that are associated with Spring Boot. I hope this makes sense to you. Now I want to go on to demo to build with Maven in Jenkins and run as a Docker container. So whatever we have been running right now, we have been running manually. Now what I want to do is I want to deploy the same application. I want to create a Docker file, and then I want to containerize it, and then I want to run that container in my Docker host. So let's see how we are going to do it. Firstly, I have a Jenkins container running in my Docker host, and that Jenkins container I created as part of my Jenkins Basics to Production course. You can create a Jenkins container by following the steps that I have defined here. If you are interested, in day 3, I believe we discussed the complete installation of Jenkins, and in day 5 we configured DOOD, that is Docker outside of Docker. And if you want to learn more about it, you can watch day 5 and day 3 of my Jenkins series. So I will be using a container that I already have created. So if I go to my terminal, I'll go here and I will just close this. I will just shut this instance down, sudo init 0, and then I will come here. So whatever we are doing in this demo will be done in the Jenkins container itself. We do not need anything else. So I will run docker ps. You see there is a Jenkins container. I will write docker exec -it and -u root. I will tell you what I am doing. I will write Jenkins, and then I will run bash. Firstly, I want you to know that I am going to install Maven in my Jenkins. Now, why do I need to install Maven? Understand, Jenkins can only run Maven specific commands if I have Maven installed in my Jenkins server. I could have installed Maven in my Jenkins container, or I could also use a Maven plugin in Jenkins, but plugin I don't want to use right now. I will be using Maven directly installed in my Jenkins container so that my Jenkins container can run Maven specific command. So I will run apt update first. And once this is done, I will run apt install maven -y. I will run maven --version. This will tell me that I am using version 3.8.7 of Maven. Remember, when we installed the binary, we had 3.9.11. This one has a previous version because the repositories that are added for my apt in this container may not have the latest version right now. And as we progress, apt update will have the latest available version, but these are always slower. That is why I said, if you want the latest and greatest, and if you want complete control, you should install it using a binary. Now that we have Maven installed, let's exit our container. And if I run docker ps, I see that Jenkins container is still running. So let's go to our browser and see what I want to do next. So Maven version, these commands we have done as part of step 1. As part of step 2, we have to create a freestyle job called Maven job. So let's do it. So I'll access my container on localhost port 8080. And then I will click on new item. Here I will name it Maven job. And this is a freestyle job. I will click OK. And I'll scroll down, add build step. I want to execute shell. That's what I'm saying. And what is that you want to execute, Varun? So let's see that in our notes. So if I come here, this is exactly what I'm going to do. I am telling step by step what Jenkins you should be doing. Understand, Jenkins is our automation server. Previously, whatever commands we were running, we were typing those commands onto our EC2 instance that had Maven installed. But now we are integrating Maven with our CI. So whatever steps we want to do, we will tell our CI server, and because our CI server has Maven installed, it will run all those steps successfully. So in the first step, we are doing what we did back in our virtual machine. We are just generating a sample code. Then we'll be CDing into my app, and then we'll be running clean package. So first we'll be cleaning, and then we'll be creating a .jar file. So that is what the output will be. -b is for batch mode, non-interactive, good for CI logs. Then build the jar, clean workspace, skip tests for speed. So right now we want it to be fast, which is why we are skipping tests. And this I have kept deliberately here so that you can use certain flags with the phases, with the Maven phases, to skip certain things, and that is how you skip tests. And there are various things you can skip, and I will let you explore those things yourself. Then I am creating a Docker file. I am using JRE now. I'm not using JDK. I'm using JRE because I just need the runtime. I do not need Java compiler here because the compilation part will be done by Maven in this step itself, and then it will generate this artifact which I am copying to my /app/app.jar as app.jar. So in this step, I'm saying use this image, working directory is /app. Whatever next commands you run will be applicable on this command. Then I'm saying copy in from the target folder. Remember, when we were running mvn package and then we ran ls, there was a target folder created, and that target folder had our artifact. Here as well, the same thing. It is just we are running these things in our Jenkins container in an automated fashion. Then lastly, we are running the command that we ran before. Java class path, we are specifying /app/app.jar because here is our artifact. And then we are saying com.mycompany.app.app, and this is what we did before as well. Then we are creating a Docker ignore file. You can see what we are doing here. And then in the fourth step, we are creating a container image. We are associating a tag called local because we are not pushing this container image anywhere. We are just building this locally. At the very last, we are echoing container output below. Docker run, we are running a container from that image. So essentially what we are saying is you run the container, and as soon as it runs, you remove it once it has done its job. Understand that our container is just supposed to say hello world, and containers do not run 24 cross 7. They just stop when they have done what they are supposed to do. Our container here is just supposed to say hello world, and once it has said that, it will stop, and we are saying don't stop it, you just remove it, which is why we have added hyphen hyphen rm flag. Now when you are dealing with web applications, you want to run them 24 plus 7, and which is why you have nginx process or any other web process which continues to run, which is why those containers run 24 cross 7. So here is what we are going to do. So I will scroll up, I'll copy this, I'll go to my job, and I will paste this here. I will save this, and then I will say build now, and this will start building this. So if I go here, I can go to console output, and this will show me what are the steps being performed, and these are pretty much the same which were performed when we were working with our virtual machine. So the point that is interesting is this is where the Docker image was created. And if you see here, if I scroll down, naming the Docker image, this one was done. And here docker run hyphen hyphen rm hyphen hyphen name is this, and this is the image that you should be using. And here you see the output, hello world. Now instead of container being in stopped state, we have removed it. So if I go to my terminal and I run docker ps here, you only see this. Even if I add a, you only see this Jenkins container. But what I can now run is I can run docker images, and this will show me all the images in my machine. And here you see cloud with varjosh java hello local, and this was created a minute ago by whatever we have defined in our Jenkins job. So I hope all these things are making sense to you. That is a wrap for this lecture. In this lecture, we took Maven from basics to production. You saw the difference between compiled and interpreted languages, why we need build tools, and what Maven actually does under the hood. We created a project, walked through pom.xml, understood life cycles, phases, plugins, goals, and looked at repositories, super pom, parent pom, and finally wired everything into Jenkins plus Docker. If this helped you see Maven the way a DevOps engineer should, do like the video, drop your questions in the comments. The GitHub repo and commands are linked in the description so you can replay the demos on your own machine. I will see you in the next one. Thank you.